This is Pre-Calculus section 2.7 notes part 2. So we were just finishing up our graph of graphical addition of the functions of f and g, and as you can see I went ahead and I erased my little boo-boo there that I had that point plotted when x was negative 1.5, y was positive 1.8. I had that one plotted a little too low, so I went ahead and erased that. But I just wanted to recap that if you're doing graphical addition to sketch a graph of the addition of two functions, you want to just make a table, just like this example. Identify your y values of each function, and then add them together, and that will be the y value of the addition of the two functions, keeping in mind that you can only add functions together where they both exist. So if one function doesn't exist somewhere, then the graphical addition of the two functions will not exist as well. The next thing that we're going to talk about today is compositions of functions. Given two functions, f of x and g of x, the composite function, and there's a little symbol missing here, it should be a little open circle like that, looks like fog. F of g is defined by, so normally you'll see it written like this, f of g of x, and to us it means this. It means that we take g of x and we plug it into f of x. And the domain of this function is going to be wherever both g of x, which is our inner function, and f of x, which is our new function, f of g of x, are defined. Meaning it is the intersection of their domains. So this should be pretty easy to remember because all of the operations that we were doing on functions previously, the addition, subtraction, multiplication, and division, that was always the intersection of their domains as well. So the domain here is going to be the intersection of their domains too. So for the first one, we want to find f of g and g of f, and then find their domains. Those are two different things. First of all, f of g means f of g of x. So that means that we are going to take g of x and we're going to plug it in for the variable in f of x. So we're going to take this x minus 3 and we're going to substitute it in where the variable is in f of x. So this is going to become 1 over, and we're going to replace that x with that family x minus 3. So that's our composite function. The domain of g of x, which was just x minus 3, that's going to be all reals. Oops, I'm sorry. Brain's working faster than the pen here. And the domain of our g of x is going to be, the domain of our f of x, which is 1 over x, that's going to be that x cannot equal 0, right? Well, you have to be careful here because when we look at our composite function now, we can clearly see that because we replace that x in the denominator with the family x minus 3, our new function is going to become x cannot equal 3. Okay, that's going to be our intersection here, the intersection of our two domains. And so we would either write that as x cannot equal 3, or you could write it in interval notation, and you could say that's the interval from negative infinity up to 3 with a union of 3 to positive infinity. All right, now let's look at this function the other way. Instead of doing f of g of x, let's do g of f of x, which is different, right? G of f of x means that we're taking the f function and we're plugging it into g. So now we're going to take this whole thing and we're going to plug it in right there. So that is going to become 1 over x minus 3. Okay. Well, the domain of our f of x function is going to be that x cannot equal 0 because the x is in the denominator. And the domain of our composition, if we look at this new function, 1 over x minus 3, okay, nothing's changed. It's still going to be that x cannot equal 0 for our domain. So the intersection of the domain of f of x with the domain of g of f of x is going to be that x cannot equal 0, or in interval notation we would say negative infinity comma 0 union 0 comma positive infinity. Let's try one more example. We've got a function f of x being x squared minus 3, and g of x is 2x minus 1. In problem number 1, they want us to find f of g of 0. So what that means is we're going to start inside. We're going to find g of 0 first. G of 0 just means that we take the g function and we plug 0 in for the variable. So g of 0 is going to be equal to 2 times 0 minus 1. 2 times 0 is 0. 0 minus 1 is negative 1. So g of 0 is negative 1. Then the second step, finding f of g of 0, really means that now we're just going to find f of negative 1, because we already know that that is what g of 0 is equal to. So that's going to become that's going to become negative 1 squared minus 3. Now we're plugging negative 1 into the f function. Negative 1 squared is positive 1, and 1 minus 3 gives us negative 2. So our first step was to find g of 0. Our second step was to take that value, which was negative 1, and plug it into f. That is what f of g of 0 is equal to. You always want to do those type of problems in 2 steps. In the last example, they want us to find f of 4. So our first step is going to be to find f of 4. So that means we just take 4 and we plug it into our f function. So that's going to be 4 squared minus 3. 4 squared is 16. 16 minus 3 is going to give us 13. And then we're going to take that and we're going to plug it back into f again. So our second step here is going to be to find f of 13, which is going to be 13 squared minus 3. 13 squared is 169. 169 minus 3 is going to give us 166 for our final answer.